What's up, guys? We're going to continue chapter 8 here with section 3. We're going to be talking about multiplying binomials. So what you're going to learn is how to multiply two binomials or a binomial by a trinomial. So make sure you're taking good notes. Here is the big gist of today. All right, FOIL. You may have heard this word thrown around a little bit with algebra. Maybe not, I don't know, but I need you to copy this down. This is going to be one of our methods for multiplying binomials, is FOIL. It's an application of the distributive property, and I'll explain that in just a second. But for now, pause. Make sure all of this is copied. Let's keep moving. All right, so there are two methods here to multiply binomials. So I'm going to look at the first one. Actually, I'm going to do this out of order. So, well, let's do the table first. Why not? All right, so to do the table method, this is similar to when you guys learn lattice. It's not exactly the same, and I really like this method myself. But what you're going to do is write each one of these terms, and it doesn't matter if this one is your horizontal or your vertical. We'll go ahead and do that one vertical. I'm going to write that one like this, and then this I'm going to write here. Now, a couple things that are important. First of all, make sure the binomial is in degree or in standard form so that the highest degree term is first. And then put those to the upper right, left corner, left. And then what you end up getting is a table that looks something like this. All right, now if this were minus, you'd want to make sure you do that. And it's just like when you learn lattice to an extent where you're going to just multiply these things out. So 2x times 3x is, that's not what I clicked, 2x times 3x is 6x squared. And then 2x times negative 7 is negative 14x. Down here, 3x times 4 is 12x. And then over here, 4 times negative 7 is negative 28. And what I'm going to do is just add all these things here. So I have 6x squared minus 14x plus 12x minus 28. And you'll notice here I have a couple like terms I could go ahead and combine. Make sure you're doing that. So I have 6x squared minus 2x minus 28. So this is the quadratic trinomial that I got by multiplying two first degree binomials. This is using the table method to multiply this times this. Now, FOIL is a really good way to show why this is the distributive property. So if I look at FOIL, the F stands for first. That means multiply this times this. Outside means multiply this times this. You'll notice here I'm making rainbows. And then inside is this times this. And then last is this times this. So what the FOIL method does is make sure that every term gets multiplied by every other term, which is what you're doing down here. 2x gets multiplied by both of these. 4 gets multiplied by both of these. Here I want x multiplied by both of these. Negative 3 multiplied by both of these. So this is the FOIL method. So I do first, which is going to be x times 4x, so that's 4x squared. Outside is x times negative 5x, so that's negative 5x. Inside is negative 3 times 4x is negative 12x. And then outside, our last is negative 3 times negative 5, which is positive 15. I go here and I combine my like terms, so I have this and this, which gives me 4x squared minus 17x plus 15. All right, so here is the trinomial that results from multiplying those. Those are the two methods that I want you to focus on. I'm okay with you using either method. I'm going to let you pick which method. So here's a few for you to try. Go ahead and choose the method of your choice. The answers will be up in 3, 2, 1. All right, so here's what I got for each one of these. Go through and just check them. If you made a mistake, you need to go back and find your mistake. Notice this one right here did not come out to be a trinomial. That's because this is a square and this was first degree. So a quadratic times a linear is going to produce something a little bit different looking. So make sure you're careful with that. Let's keep moving here. Oh, it's getting warm outside. It's spring. We are so excited we wet our plants. That's funny. I don't care who you are. That's funny right there. All right. Applying multiplication of binomials. It says a cylinder has the dimensions shown in the diagram. Which polynomial in standard form best describes the total surface area of the cylinder? The surface area, here's the formula for this. The surface area is 2 pi r squared plus 2 pi rh, where r is the radius and h is the height. There's a lot to this one, so make sure that you're hanging with me. All right, so I'm just going to go ahead and start substituting things in. This right here is my r. This right here is my h. So I'm going to write 2 pi times my radius squared, which is going to be x plus 1. And I'm going to write it out long ways, because when I square something, I'm just multiplying it by itself. So x plus 1, and then x plus 1. And then plus this part right here, I have 2 pi, the radius, which is x plus 1 times the height, which is x plus 4. Big and nasty and ugly. From here, I'm going to multiply these things. I'm going to just leave these 2 pi's out here in the front. So I'm going to multiply. I'll use FOIL on this. So I have 2 pi times, let's see, that's x squared. And then x times 1 is 1x. X times 1 is 1x. So that's going to be plus 2x, which, by the way, this is a special case. We'll look at those in the next chapter. And then 1 times 1 is 1. And then over here, I get the 2 pi. And then I get x times x is x squared. I get x times 4 plus 1 times x. So that's 4 plus 1 is 5x. And then 1 times 4 is 4. I need some equal signs in here. I apologize for not including those. From this point, I'm going to factor out a 2 pi. All right, which means these both have a common term, so I'm going to factor that out to the front. This will make more sense as we go, but for now, I just want you to copy along. So when I factor that out, what I'm left with is x squared plus 2x plus 1 plus all of this stuff, plus x squared plus 5x plus 4. And we'll talk again more about what it means to factor something out. But from this point, I'm going to go ahead and combine some like terms. So I still have the 2 pi in the front. I have x squared and x squared gives me 2x squared. 2x and 5x is 7x. And then 1 and 4 is plus 5. And then I need to get rid of these parentheses, so I'm going to just distribute this 2 pi to everything. And what I end up getting is 4 pi x squared. 2 times 7, or 2 pi times 7 is 14 pi. And then keep the x. And then 2 pi times 5 is 10 pi. Now, I know that that is big and ugly and complicated, and some of you are looking at that and freaking out. Don't. Hang with me. We'll talk more about factoring coming up, so just bear with me on this. For now, just copy this down. You're just going to follow this example the way that it is. All right, so let's keep moving along. It says multiplying a trinomial and a binomial. To do this, the book has you set it up in the way that you used to learn math, so that I'd have 3x squared plus x minus 5, and then underneath it I'd put 2x minus 7. And then you'd multiply this times this, this times this times this. And that's great and all. There's nothing necessarily wrong with that, but my preference for this is a table. So I'm going to go ahead and write that out, just like we did before. So 3x squared, x, and then negative 5. And then right here, I'm going to have these terms. So I have 2x, and then negative 7. And we'll create our table to keep our stuff separated. Make sure that minus goes with that 7, and this minus goes with the 5. So from here, I'm going to just multiply. So 3x squared times 2x is 6x cubed. 3x squared times negative 7 is negative 21x squared. Here I have x times 2x is 2x squared. X times negative 7 is negative 7x. Negative 5 times 2x is negative 10x. Negative 5 times negative 7 is positive 35. All right, so there are all my terms. You'll notice this kind of works like lattice in the sense that all these things work going diagonally. It's not always that way. But if you see some things, you could go ahead and start combining like terms. For instance, this and this are like terms, and this are like terms. So when I write this out, I'm going to start out with my largest degree. So that's 6x cubed. Negative 21 and 2 is negative 19x squared. And then here, negative 7 and negative 10 is negative 17. And then just add the 35. So I was able to, through my table, to combine some like terms as I went. So multiplying a trinomial by a binomial is going to produce something like this. All right, I like the table. I think it's the most straightforward way to do that. It keeps your work organized because otherwise it starts getting sloppy and then you're adding and you're having to line up like terms and all that. I prefer the table. If you want to see an example of this, you can check it out in your book, but I'm going to go with the table. Let's keep going. All right, here's one for you to try, so go ahead and pause. The answer will be up in 3, 2, 1. All right, so here is what I got by using a table, so check your work against mine. And I believe, yep, that's it for today, so make sure you take good notes on this, and I will see you guys in class.